My name is Kaveh Razazian, work for Sagemcom, and thank you to open up a time slot for me in the last minute. I called you a few days ago. My presentation will cover some of the work we have done on the hybrid technology, G3 hybrid. And what we did was that we did a small POC in India. And I wanted to share with you some of the results that we got from this field trial. It's very interesting. It's informative information that it can help us in the future how we can proceed with this concept of hybrid technology. Before I go to the description of what we have done, I just wanted to say something about the hybrid technology. You know, as Mark mentioned at the beginning of the meeting, there is 80 million of the G3 PLCs in the field, and 35 million is in France. You know, when you talk to other DSO, like a leading DSO like Iberdrola, they have 20 million of the prime solution PLCs working. One thing is that we are moving to the hybrid technology. It does not mean anything that the technology that is being used, the PLC technology, was having certain problems. Now we are moving to another solution. Then after 5 years, we're going to say that the hybrid not working, we put a cellular hybrid. And it's not the case. The case is that both the large DSO, like Enedis and Iberdrola, arrived to the conclusion that the hybrid solution is the next step. Why? Because the use cases are changing. When we start the G3 PLC in 2010, and at the same time was Prime in 2008, the expectations was built based on the legacy technology that it was there. Legacy technology was FSK. And they were achieving a KPI of 80-85% with a lot of field work. And they come up with a new solution, OFDM technology. The expectation was achieving a 95% KPI, 96% KPI. It is the numbers that we were looking for. Today, the market becoming very competitive. The European DSO, they have a very good idea about their network. But when you go global, they want to have a solution, and the solution they wanted to have, they want to have 100% KPI. I mean, this is the thing. Then they do the comparison, and they do the competing technology. The competing technology like a MBIoT, cellular, they can get at 99%. Their expectation is that to get the higher KPI. The second is that they're asking more capability, accessing to the multi-energy, accessing to the home, controlling the load management. And some of this application, you really need a secondary medium to be able to make it that connectivity. The last point here is that this technology started from Europe. And when we are in Europe, when we have a problem, Enedis has a problem, has a engineering, has a big group of engineer experts go there, you know, they identify, they write a very sophisticated software, Prime, Iberdrola writes a very sophisticated, manage their network, they send the people, is a very standard approach. But we are going global. We cannot duplicate this process in Indonesia, Malaysia, Egypt, Russia. We cannot send the people, and we cannot educate the DSO that what sophistication they have to do, what type of engineer they have to hire. That's why we have to make this technology simpler. And that's why we are pushing on the hybrid technology. That is the case of the use case for the hybrid technology. It's not because the old technology is not working anymore. But having said that, the technology that we are using, they use is a G3 PLC. We have the RF technology with the 50 kilobits, and we are using the FCC band. full FCC band, which we were having around about 180 kilobits of data rate, and with the 50 kilobits of RF, we use this application in the field. Just the other point is that is a good decision that we made at the beginning of the hybrid technology, and today we can talk about it. A year ago, we talked about hybrid. Today, we are doing POC, which is a very fast process, means that it took us about a year. We are doing the proof of concept because the system that we design is not too complicated. And you can see that our RF and PLC are two different paths. They are not intertwined. Means that debugging, understanding of how the RF works, understanding how the PLC works is very easy because there are two different paths of communication. Each has its own MAC layer. Therefore, the only area is the decision making. This is the abstraction layer where we make a decision how to switch. Means that the system is very simple. If tomorrow we go to the field and we come up with some ideas, it's very easy to work and improve the system. And that was the decision we made. At the beginning, if you recall, we had about a month of thinking that whether we have to mix these two layers together or we have two independent layers. To me, I am arriving to the conclusion the decision we made at the beginning was a good decision. Now we can do a lot of work on that. The other point that I wanted to say on this presentation, the nice thing about the RF, I mean the RF and the chip supplier that they're giving you the RF, the nice thing about it is that the chip, a single chip that we put it on our product can operate wide range of frequency. And this is very nice. That means that when we are making a product, the product, by changing the software, no hardware change, I can use it in Europe, I can use it in India, and I can use it in Malaysia because Europe is 866 and then Malaysia is 920, and single chip can do it. It means that the export of the technology to different region is not very complicated. The complication is the transmit power for each regions are different. For instance, in Europe is 14 dBm, and then you go to India is a 26 dBm, and that's the only the difference are. But the hardware part and the technology part is all by software we can modify it. And this is the area that we did the pilot. We work with the DSO. I cannot give the name, but there is a press release will be coming up with the utility that we work with, and the area they gave us that we put the 20 meters. The pilot wasn't really big pilot, but we are planning to do more installation. But we did with the 20 and at the residential home, this area. And couple of points I say that since we had a prototype device, it wasn't exactly, the transmit power wasn't exactly at 26 dBm. It was at 24, means that we were about 4 or 5 dBm lower. I mean, considering that the system wasn't in the perfect condition that it gives the highest transmit power, means that considering the fact that we were on the lower transmit power. The other point that I wanted to say that even though the area was very small, means that we did about 20 meters in this area, I wanted to give you some point of reference to understand the situation. We did the noise measurement. We have a tools that we can do the noise measurement per device. That is the noise, the red one. This is the SNR, and this is the signal level. We did the measurement at the substation, means near the DCU. You can see that the signal of the DCU, when there is no distance, right at the point, is 120 dB microvolt. And you can see that at that location, the noise is at about 100 dB microvolt. our experience, we have done a lot of deployment in the different regions, Egypt, Malaysia, Indonesia. We did a lot of tests. Noise, in the few area in our deployment, we identify 100 dB noise. 100 dB noise is a very unusual noise. It's not low-level noise. Usually, the average noise that we experience in every network, if you go to an ADSN, the average noise will be somewhere between 55 maximum to 80. That's the highest you can see. That's the range of the noise. When you get to that 100, that is the area that normally the PLC is not working. And even though the area is very small, the nice thing about it was that the noise was extremely high. It was a very high level of noise. And we did the measurement. And the noise was everywhere. I don't believe that this is an appliance noise or something coming from appliance. I think that this is because of the age of the transformer. I think the transformer was generating this high level of noise. I don't believe it's coming from the appliances. But the noise level was extremely high. Just to prove the case, we went to other part of the India. We just randomly picked the places to measure. And you can see the noise level. You see the noise level, I said that. This area that we work, although it's small, it wasn't simple. Originally, when I went there and I saw that this is like we connected, it's going to work because 20 meters is not a big number. But actually, it could end up to be very noisy environment. Means that it is a high level of noise. It's 100 dB SNR, 100 dB microvolt. And then this is the other area of India that we did the noise measurement. The second point, very interesting. Even though this area was so small, we found another interesting phenomenon. The interesting phenomenon was that there are two rows of the apartment building, this row and this row. The interesting about it is that this, first of all, the meters are on the first floor, all the meters on the first floor. And the meters, the entrance to the building is opposite of each other. Means that I put the meters right here, and I put the meters in front of this building. Means that the RF signal are exactly in the opposite direction. That means that the RF signal from here is a strong going this way, the RF signal coming that way. And in the middle is actually the very weak signal. Means that it was come up to be a very good area because I got the very high level of noise on the PLC part. And I got to the point that the signal is going to two opposite directions of RF. That means that now the beauty of this is that what the PLC can do to solve this area, this region. And then I wanted to show you it's not really graphical. We did the measurement. You can see that we put the sniffer here and measuring the signal of the meters at this location. Means that this sniffer is measuring the signal reaching to the sniffer from the front. You can see that 98 is very low. We can operate at minus 85. Means that the 98 or 90 for us at that point is a very, very low RF signal. And then we put the sniffer in front, and now we cannot see the back because it's a minus 101. The RSSI value is, and that shows that this is our two opposite direction we are going. Now, and this is the result. You can see that this building in the back, the RF signal is coming and this one uses the PLC communicate to the, means that if we didn't have that PLC communication, the KPI of RF would have been about 50% because the back part would not be connected. And in addition to that, if we didn't have the RF, Because of the high level of noise, our KPI would have been at 40%. Means that we would have had a similar problem. It's just these two technology together they were able to do the communication. We have this technology for 3 months. We are collecting the data every day, and the KPI is 100%. We are making it more aggressive now. We are start collecting data every 15 minutes to see that when it's dropping. And the other issue with this area is that they have a lot of power outages. Means that sometimes it's a power outage, we cannot do the collection. But what we did was that we are taking the routing topology every 15 minutes. Means that we can monitor the routing topology every 15 minutes in this network. I'm just going to give you some of the time, like at 14:30, the network was like that. At 10 in the morning, the network was like this. The network keeps changing, and then the devices keep adjusting itself accordingly. And then I have another one at 3 o'clock, the other one at midnight. And we have this topology every 15 minutes. And then that shows that this RF technology is evolving based on the network condition. And then as the network condition changes, and we can see that the PLC, some network start using the PLC, and sometimes they use the RF. And yeah, I have more. This is the topology between 6:30 a.m. to 12 p.m. This one is 5:30 to 6 a.m. another day. And you can see that this time, this one uses the RF to communicate with this, and then it goes there. However, what I can say from this experiment, there is still room to improve the technology. The technology has to get much smarter on the decision making. I still say that we have this idea of changing the network based on if the PLC is not working, then you go to RF. That concept doesn't really work in the field because the field is not binary. It's like one goes 0, one goes 1. The network goes to PLC works, but is not working very good. And RF works very well. Then you have to be smart enough to distinguish that RF is very good and PLC is okay. Then you have to go. We have to develop those kind of intelligence in our system in the next generation of product. But otherwise, and then here we were getting the daily. Usually the meters in the front, they like to use the RF more often. In the back, it's like a RF and PLC is in the average. They are using 50% of the time RF, 50% of the time PLC. And then this one is that what I said that about the power outages. I just wanted to show that we had a lot of power outages, and even within the power outages, the system was working. And the other thing that I wanted to say, okay, this is the KPI that I already mentioned. We're getting 100. Oh, this one, something is very important is that we did the KPI at 24 hours 100. Then I said that we did the 1 hour collect. We did recovery. Recovery means that if you send a message and you don't get the data, you will ask one more time, two more times. If we do with the recovery, considering that the network, we have a power outages, means that every day we had the power outages, without any recovery, and then collecting every 1 hour, we're getting 97%. If you are doing 1 hour collect without the recovery is 83%. It's the numbers of collecting every hour collection. The other point I want to say about the last gas, we did implement the last gas. It's not exactly the last gas that we are talking in the specification. It's similar to one. And we didn't even test it. When the power outages is happening, we are able to get the message. Means that for this particular one, this is the serial number of the meter. And this is the time that the power outages happen. And this is the time that we were able to register it in our network. I just wanted to show that it does work, but we have to improve the concept in our specification. But this new last gas concept for the hybrid does work. And it's very important because a lot of DSO, and especially in Asia, they wanted to have the last gas capability in their network. Otherwise, just the last point is that this measurement that I was saying, that we have a tool that it does hybrid, means that it has a PLC capability as well as a RF capability. This device can go and monitor each meters and can provide you with the signal and the noise of every particular. It's not a network. Every particular meters, we can find out the noise of the meters and then the power. And this is the way that we did the measurement in the field. This would conclude my presentation. Thank you very much.